Let's say find the value or values of x comma y. Find the solution set for x comma y. Acha, I can do this now. Solution set for x comma y such that this number is divisible by 72. If you want a number to be divisible by 72, what should it be divisible by?
8.
Only 8?
9. 8 and 9.
8 and 9. We have to ensure the number is divisible by 8 and 9. Okay. If the number is divisible by 99, what should it be divisible by?
9, 11 and 9.
11 and 9. So, wonderful things. Please solve. When you get a question in this format, that is when you solve. Tell them again. What answer are you using? 5 sets. Okay. And this is why we say अपनी क्लास में शुरुआत में सबको लगता है बहुत लाइट चल रहा काम, जब धीरे धीरे बढ़ना चालू होता है तो दुख हो जाता है. This is not very difficult yet. अभी तो और difficult आएगा इससे, but this is significantly more difficult than finding out possible remainders with 4 and 8. Lots of small little details that you have to pay attention to. अच्छा, आई देख लो बहुत देर हो गई. Find the value of x comma y such that this number is divisible by 72. If it has to be divisible by 72, it has to be divisible by 8, it has to be divisible by 9. Right now, I'm looking for, first thing I'm checking for is divisibility with 9. This entire number adds up to 49 plus x plus y is equal to a multiple of 9. 49 plus x plus y is a multiple of 9. Can I now say x plus y is equal to 4, sorry not 4, 5, or x plus y has to be equal to 14. Multiples of 9 existing after 49 are 54 and 63. Can I also extend it to x plus y is equal to 23? इसमें 9 ऐड किया. The next multiple of 9 is at 72. Can I get to x plus y is equal to 23? Is this a possibility? No, because if I am adding two single digits, the maximum sum I can reach is 18. This is more than that, so this is not possible. These are the two possibilities for x and summations of x and y. Now, if I want divisibility with 8, I need x168. I want x68 to be divisible by 8. 068 not divisible. 168 yes divisible. And if once I've identified 168, can you see this is increasing in steps of 100, and it also has to be a multiple of 8. A multiple of 100 and a multiple of 8, which is the smallest number that is divisible by both of them. It is 200. So x could take a value of 1, or x could take a value of 3, or x could take a value of 5, or x could take a value of 7, or x could take a value of 9. All of these are possible values of x. Correspondingly, can you see if x plus y was equal to 5, y would be equal to 4, y would be equal to 2, y would be equal to 0. But these cases would not be possible. Y would have to be a negative number. I have to ensure that one of these two conditions and one of these 5 conditions is simultaneously true. So if x can take these 5 possible values and x plus y is 5, Then these are the possibilities. Versus if x plus y is equal to 14, x equal to 1, not possible, y would have to be 30. If x is equal to 3, not possible, y would have to be 11. X equal to 5, y would have to be 9. X equal to 7, y would have to be 7. And x equal to 9, y would have to be 5. So we get 3 cases from here. And we get 3 cases from here. Altogether, we are going to have 6 cases. And those 6 cases are 1, 4 and 3, 2 and 5, 0 and 5, 9 and 7, 7 and 9, 5. These are the 6 cases that are possible. So which case did we miss out on? कौन सा नहीं दिखा?
5, 9 वाला.
5, 9 वाला. Okay. ठीक है. Why this is wonderful is now when we come to the second version, second question on the page, find the value or values of x, y such that the same number as the previous one is divisible by 99. The working for 9 is already done. We don't need to do new work. We already have this result, x plus y is equal to 5 or x plus y is equal to 14. Now we need remainder with 11. Let us do that. (14 plus 6, 20, 28 plus x minus 6 plus 7, 13, 13 plus 8, 21. 1, 5 has to be some multiple of 11. Okay, so we get to x minus y is 7 plus x minus y is equal to some multiple of 11. Some multiple of 11. Can I now go x minus y has to be 11 and minus 7. I brought the 7 over to the other side. Or, given this is a negative remainder, can I say x minus y is equal to 11n plus 4? 11n plus 4? No. X plus y would be equal to 4 or x plus y would be equal to 15. Is there any other possibility for x plus y?
No.
No? Think. Sorry.
X
Written
minus
x
y.
minus y. It is not x plus y, it is x minus y. So, back to here. Is there any other possibility? Can I say this is actually not a possibility? Two single digit numbers cannot have a difference of 15. What can two single digit numbers have a difference of? Is this possible?
Yes.
This is possible. This is possible, where y is larger, x is smaller. And then this is possible, x minus y. Now, a basic idea. If sum of two numbers is odd, their difference also has to be odd. If sum of two numbers is odd, the difference also has to be odd. So, I will have two sets of simultaneous equation, x plus y equal to 5 and x minus y is equal to minus 7, giving me 2x equal to minus 1, sorry, 2x equal to minus 2, which I can rule out. This is not possible at all. X cannot be a negative integer. So that case is not possible. This case is not possible. So we are left with this wonderful version. Let's read this. X plus y is equal to 14 and x minus y is equal to 4. Can I get to 2x is equal to 18, x is equal to 9, and therefore y is equal to 5. Find the values of x, y such that this number is divisible by 99. X equal to 9, y equal to 5. Here we had 6 cases coming up. Here we have just one precise case coming up. And even in that one precise case, there is a lot of writing. There is also an odd even idea coming in. Lots of case making. Not something that people can get to very, very quickly. This is not the highest level of difficulty that you can face, but this is definitely not something that you catch on very easily as you did with the earlier questions. Are these two questions understood?
Yes, sir.